Good morning, all. In today's section, we are going to discuss about the sockets, system calls, iterative and concurrent server, how it is processed, and so on. So let us talk about the socket first, because as we know that already we have done certain lab exercises for establishing the connection between the client and the server, and how the communications can be done through the different protocols and so on. Let me introduce this socket with the socket. What is socket? It is a node or an endpoint or a machine. So in order to activate the endpoints, we need to do the initialization of the machines. So how we can do that? Socket, and in the bracket we'll be having three different features over there. One is the domain, another is the type, another is the protocol. So domain, when we are talking about the domain, we know that there are two addressing schemes we are introduced with that. One is IPv4 and another is IPv6. So talking about this IPv4 and IPv6, it will be in the domain details. And coming for the type of the type, in order to give some details about the type in the socket, it is like the UDP or TCP. UDP means it is a datagram, and TCP means it will be based on the string. And coming for the protocol, it may be any protocol, I said protocol, TCP protocol, whatever the protocol we are giving, it may be termed as a zeros or ones. So likewise, we can number it. So this is activity done in the socket initialization. That is activation of the endpoints. And the next flow of this socket is binding. Binding is a handshake between the server and the client. Whereas this binding is the next step of the socket initialization. That is, it has to have, what are the details it has to have is, it must have the address plus the port number, addresses to the server, and the socket address will be in such a way, it will be having the IP address plus the port number, whereas the IP address will be how many bits? 32 bits, yeah, correct. And the next port number will be how many bits? 16 bits. So totally 42 bits will be there. So the logical addressing and the MAC address, whatever we are going to provide, will be having all these 42 bits of details over there. In the binding, we will be having the address. The next flow of the socket is listen. So when we are about to discuss about this listen, we know that the uh, connections, that is request from the other end of the address, whichever is pushed towards it, it will be listed as a queue. Okay, queue. When the queue is full, what will happen? We cannot give the connection. We cannot establish the connection over there. So what we will be doing, we will be making that to wait for some time until the queue is cleared. When the queue is cleared, we will be allowing the other one to make the communication in. So this is what is done in the listening mode. And coming for the next flow, it is a accept mode. In accept mode, we will be initiating the call that this person is communicating to you. That is the call establishment and be initiated first. And the next is the connect. Mm, what is the dial of that number, which number we are going to connect it. All these things are done in this acceptance mode, and then we are going to connect through the server or the client, whichever the port end is going to communicate over there. So once the server is initiated, the client will be requesting for the communication. Once the queue is uh, empty, then the connection will be established to that address which is requested for the communication mode. So this is what is done over there, and the last is the send and the receive mode of the messages, which has to be communicated between the client and the server. This is the small flow. I am giving an introduction about the sockets, and then as you are seeing that coming for the next topic of this socket, how to initialize the socket, everything we need to know. That can be done based on the details which can be provided here. Before that, this is a socket what I am talking about. You can see all the socket programs will be run in the application layer, and the socket application interface will be initiated with the type of the protocol what we are going to use over there. So as we know, the domain will be there. Another thing, the type which it belongs to, like it may be a UDP or TCP, and the protocol which is initiated for the socket programming. These are some of the file descriptor. So in order to, these are some of the listed descriptors in the sockets. To perform the file input output operations, we will be having the file descriptor. And when we want to provide, perform the network descriptor input output operations, we will be using the socket descriptor. When each activity in the socket is identified by this socket descriptor only, socket descriptor is over the network we will be using, and the data type of the socket descriptor is socket, and the hack, whichever the header file we are invoking for the socket is winsock2.h, and we will be defining the type of socket which is initialized of int, which is unsigned in or signed in, whichever may be, we can initialize with the socket. And the operating system will be using is Unix operating system for the specified file, what is the descriptor, and that will be created with the descriptor table. These and all we have seen in the first unit itself about the socket description, how the socket description table is created, socket descriptor is created, how the table is initiated with the certain invoking operations and so on. So the Windows operating systems keep a separate table itself for the socket descriptor, and it is named as a socket descriptor table, and or otherwise it is short term, it can be called as SDT. For each process it will be defined in such a way. And when we are creating the socket, we need to know what is the syntax of it, and the API of the socket contains a function of socket, and that can be called as a create a socket. So whenever we know that what is the header file we need to use, it is a winsock2.h, and the socket S is created, and S is equal to socket of AF underscore innet and sock datagram. So as I mentioned, if it is a datagram, it is a UDP protocol. Datagram, it is a UDP protocol. The socket is not usable yet. We need to specify more information before using it for data transmissions. So what are the different types of socket we'll be having, or the Steam socket? And this is say like we know that protocol type we are giving, protocol we are giving, it is a AF underscore innet we have given. When we are using the Steam socket, what is using is it uses a TCP for connection oriented reliable communications, which is identified as talk underscore stream. So when we are initiating the socket, we can see that we will be initiating with the sock underscore stream. What is that? It is the TCP protocol. And datagram protocol, we know that it is a UDP protocol. It will be, as I told you before, that TCP will be initiated with the sock underscore stream or sting. It may be in the datagram, we know that we will be using the UDP protocol. So sock underscore dgram will be used over there. And that is what is mentioned here as a UDP protocol for connection, less communications. So this was the initiation for this other type of sockets. And another is a very simple protocol, that is raw socket, which is uses the IP directly. So it will take whichever the IP is initiated at that network, it will be taking that IP and working on it. So by identifying the socket by sock underscore raw, we can know that which type of socket it belongs to. And when we are seeing this type of data structures for sockets, we must know the two things, what it is happening here. The one is the socket descriptor table. When the socket descriptor table is initiated, it will be pointed to the data structures for a socket, so which it belongs to. So what is happening here? When an application process calls a socket, the operating system allocates a new data structure. Before getting into this data structure, let us see about the system calls and then come back to this data structure, so you can you may know that how this socket a system call is created, so that how the socket will be creating calling the operating systems itself. So while defining this system call, we must know that how the system call works. So I will give you a small example for the system call. It is a system call which provides an interface to the servers or uh, available by an operating system. So what is happening here? What does it mean? Because as the program as a programmer, we must know where our program is compiled or run and so. So when it is initiated, when the program is initiated or progressive processes started over there, we must know where it is running over there. There are two modes available for a program to run on. The first mode is the kernel mode. The second mode is the user. So as correct, as you have mentioned, is a user mode. What is the difference between this kernel mode and the user mode? First, we need to know about that details. So for that reason, I will explain you what is a kernel mode. The kernel mode has all access for memory, hardware, and resources. So as we are talking about this kernel mode, it is a more privileged node because directly access is there. Whatever, whichever it needs, it can take it from the resources, or it may be requesting the memory to point it out this process and so on. It can be initiated much more. Coming for the next term called the user mode, it has no access to the memory or a hardware or resources or what is happening here. It is what is the difference? It is not having any privilege at all, as I mentioned for the kernel mode. So what is happening here? How it can be run in both the ways? That there are also many questions. So I will tell the small drawback which is in the kernel mode. Even it is a privileged mode, it is having some drawbacks over there. The first drawback is, sorry, it is there is a drawback where what is that means? If a program is crashed while running or compiling in the kernel mode, usually what is happening, it crashes all the whole entire system. So we cannot imagine that crashing the entire system, operating system, totally damaging when it is crashed, when the program is crashed in the kernel mode. What is the safer mode to run the program? So that is what the user mode comes into the play. So user mode is a safer mode of operations. It is very good enough to explain about that about this. And this was a clear picture about this system calls, where the program is run initiated to run in the whether it is in the user mode or in the kernel mode. We know what is the difference. We know how it is running. We know now what exactly is the system call, how it is going to be called over there. So the program needs access to certain resources, or it may be hardware or operating system, whatever may be. So the program needs to initiate the call first. How the program is going to initiate the call? How it is going to happen, or in what way we can do that is, it is there, the part of the system calls is coming into an account. As I mentioned it is an interface between the process and the operating system, where the process can be handled in different resources to in order to request for the resources or the hardware or the operating system, whichever it's done through the system call. I will explain you lately how what is a clear example for the system call. It will be a good details to be known for you also. So the call that the program makes is me the system call is known as the system calls. The system call in the program in which computer program requests a service from the kernel of the operating system is known to be the system call. So that is what the system call is defined as an interface between the process and the operating system. What are the details it will be providing is the services for the operating system to the user program via application program interface is known as the system services. System call services. Interface to allow user level processes to request services of the operating system. The system calls are the only entry points into the kernel system, or otherwise it is not having any access to the memory or hardware resources. How it will get the resources, how it will use that resources, that is what the system calls is meant for. Hope you understand the system calls. Let us get into a small example for this. And these are available, how it will be available, these calls, how we can initiate these calls is a routine. As a routine we can call the system calls, which is written in which language? C or C++. Obviously, we will be using C or C++ for calling this system call functions. Okay. Let me give you a small task for you in order to do that. How you can initialize a system call for the process of copying a content of one file to the other file. That is, from the source file, you need to copy the content from the source file and you have to transfer the data to the destination. How it can be done? So you think and tell me how the process will be done. Based on that, I will give few detail about that. First, you have to have the file name, acquire the file name. That is one system call. Another is you have to write a prompt to the screen. That is in order to get the file name of the source file. That is a prompt you have to write. That is another one system call. And the third one is you have to accept the input of the file name which you have given as a prompt file name. So that is where the next one is belongs. That is also a system call. And then you are going to acquire the output file name. And then you have to take the write the prompt for the output file name. And then you have to accept the output file name. Then these are about whichever I am listing, all are system calls. All are defined as a system calls, which you are requesting the operating system or the resources to handle this file name in order to store the file name in the drive locations where it is required in the memory. Okay. So what is happening? These system calls, how it works, and not only it stops here. Only getting the file name is the operations. No, what is the operation we need to perform? We need to copy the source file content to the destination's content. How it can be done? So we need to check whether this file has been already there or not, or otherwise if it is not created, what is the error it is going to throw us for this system call. Everything has to be handled. Hope you understand the flow what I have told. And then moving on to the data structure of the socket, which we are discussing. You know that when an application process calls a socket, what is happening here? It is a system call. The operating system allocates a new data structure to hold the information for communications, and as well as it will fill the new entry in the process socket descriptor table. That is socket descriptor table. Already I defined that socket descriptor table. What are the details will be there in the socket descriptor table? What is the pointer which is uh, listed to the operating that is data structure for a socket? How it is done over there? So a process may use multiple sockets at the same time. The socket descriptor table is used to manage the socket for this process, and different processes use different SDTs. As you know, first, if the single socket is initiated with single operations, it will point to the single operation what it is. So if I am initializing, it will go to the header file and see that what is the libraries available. It will initialize or not. It will check it. That is a process. First, a process. If it is there is a multiple sockets available, multiple sockets are created. So it will be containing many fields, but the system leaves most of them unfilled. If there is no operation happening, it won't fill over there. So the application must make additional procedures calls to fill the socket data structure before the socket can be used. So what is happening here? So whichever the data is data structure, the data is allocated, the details is allocated for this SDT table, then it has to have what operation it has to perform. It has to point towards that operations and so on. So the socket is used for data communications, the two processes which may locate at different machines, so that socket data structure should at least contain the address information, example IP addresses, port numbers, extra will be there, so that we know to which destination it has to transfer the data or which destination it has to process the data and so on. Hope you understood. Any doubts here, you can chat. It's a simple functions used in the client program. As you know, the socket is created with the socket descriptors. It will be connected to the remote server, read and write, communicating with the server, close the end communication by the closing the socket descriptor. We have discussed this earlier in the flow of the socket, what we have done over there. So initially we will be having the domain type protocol. These and all I have already explained to you. And what is the domain? I have explained about that PF underscore innet. That may be IPv4 or IPv6 also. So the type is a socket stream or socket diagram, which is UDP or TCP protocol. And coming to the protocol infrastructures, it is a socket stream or a socket diagram where it will be depend on the TCP or UDP protocol. And then this is a connect operation functions. The connect functions is used to what? It used to communicate between the details, which is after binding the addresses, everything is linked, and it has to listen. Yeah, during the listening process, the address will be invoked and the calls will be invoked over there, and the socket descriptor will be having the server address and the address size also, and remote address port are also stuck over there. I have already mentioned that the address of the IP address will be how many bits? 32 bits, and the port number will be 16 bits. Totally 42 bits of data will be accompanied here. And this is very simple details about the read, write, and close operations. Why we need that is we need to initiate the communications after the call is evoked. If the queue is empty, the call is evoked over there. That time, this read, write, or close operations taking place, and this will be handled in the write int socket void with the buffer size and length also. The arguments, whichever it is, will be there, will be having the socket descriptor and buffer. We know the descriptor table, how it will, ASD will be there, and data and the length of the buffer will be there, which is very prominently needed. These data has to be there over there so that the size is determined based on the protocol which we are using that we already discussed in the unit 1, and how the receiving of the data will be. Usually the same thing will be replied by those certain data definitions what we have given for that protocol. So the sizes, buffer sizes, and the buffer pointer, where it is pointing, everything will be detailed again and will be given over there. And at last, if the communication is the handshake is process is over, the communication is done over there. Hey, I'm here. Yeah, the server listens to you and acknowledge you. The data is received over there, and the client also is giving you the responses and requests. Everything is processed over there, and everything is over. We need to close the socket. So the closing the socket into close of int socket will be called for, and the function is closed over there. So what are the functions used in the server program? These and all we have discussed in the first thing when I am giving the flow of details of the socket. I have discussed about these functions, socket creations, that is initializing the socket or the node or the end or the machines. Everything we have talked about that, and binding. Binding, what is binding? We will be happy. We have to associate with the local addresses. That is the address, IP address plus the port number. These things is the binding, and listening is the coming waiting. That is queue. You need to remember the queue here. Where if the queue is empty, the connection will be established over there. Exit. Exit is the interconnection between the messages, whichever you are sending to and for. You have to accept the client which is waiting to initiate the call. Like you are having landline, two landlines. If you want to communicate with them, what you will do, you will be ringing the number and then you will be established. The other end has to pick up the call and say, hey. So the establishment of that two things is the acceptance of the incoming connections over there. And we need to read or write or communicate with the client. So this is a message or text or something we are going to give over here. So then that's what is done over here. And the closing of the socket descriptor is done over here. So these are explained again with the bind local address port and how it is initiated over here. Again, the same thing is repeated for you to see how this initialization and the binding has been done over there. It's a handshaking process, as I mentioned. Is you can see the socket. and the details of the socket address and the address port will be there, and these things are in listen. And coming for the listening, you know that the pending connections, what are the pending connections we are having, and we must listen to the socket which is created as a backlog. And you know that arguments, socket descriptor, acceptable, backlogs, everything will must be written with a 0 on success and 1 with the error. Okay, already we learned about the checksums also, where the error data must be discarded and how it can be discarded, how the checksum details can be calculated by summing all the data, input data with the mm, complement of one. So for generating the checksum number and so on, we have done with that padding, error, error corrections codes, everything we have learned. And coming for the accept, it is very very prominent role it is playing, because after binding, after the handshake has been processed, the calls has to be initiated after the queue has been cleared with the details that okay, the connection is the way is clear, you can initiate your connections over there. That is what is done in the acceptance. So the socket details will be there, and the address of that, address length of that buffer, size, everything will be given over here. So the accept call blocks waiting for a client. When the cloud blocks will be initiated, because the queue is not having any picture over there, it is having some data over there already, waiting data will be there, you have to wait for some time, so that when the queue is cleared, you can be entering into the queue to listen over the client establishment acceptance over there. So that is what it's done over here. uh, okay, this is different. With this, we are closing the uh, call sections of system calls, system and concurrent, and then concurrent process. And then we are having iterative concurrent server is whenever we are initiating the fork, um, that is connection, that is communications, we know that it may be occurring iteratively or it may be occurring concurrently according to the message which is sent parallelly or processed parallelly. That section is known to be the iterative, or it may be the concurrent server operations. So with this, we are winding up this section. Thank you so much for listening. Thank you all. Have a nice day.